Yes, so hopefully everything is good. Yes, so it has started. Okay. So let's move on towards our lecture number 10 of physics optional. We will start with the 2012 year 2012 PYQ. Okay. So the PYQ says that you are this. Okay. What is this? This is basically time independent Schrodinger wave function. Okay. This is basically time independent Schrodinger wave function. Okay. Or you can say not Schrodinger wave function. You should say wave function. Okay. And it is given like this. Okay. It has been given like this. Okay. And it is applicable for this range of value of x. For this range of values of x, it is applicable. Okay. And k is greater than 0. Okay. So you have to basically find out the potential function once again. Okay, this is 2012 year PYQ. Okay, so potential function v of x you have to find. It is a given that as x tends to a, okay, v of x tends to 0. It is given over here. Okay, and also e you have to find out. Okay, so what will be the approach? I had already told you in the previous classes that whenever time dependent function will be given, some formula will be little bit different, and when time independent function will be given, the formula will be different. So for time independent function, I had clearly told you one thing. For time independent function, I had clearly told you one thing, that h psi equal to e psi is the formula. Okay, this is time independent one. Okay, so clearly from here I will substitute the h value. So as I put the h value over here, so the value of h is given in this way. Now I will not use partial differentiation over here. Instead I will use full differentiation. Okay, psi of x equal to e psi of x. So I have basically put the h value. Okay, got it. So I have put the h value. Now I will put the psi x value also. Okay. Now I will put the psi x value also. Let us go very much step by step. Okay. Let us go very much step by step. And psi of x will be your ax e to the power minus kx. Okay. And this will be equal to your e a x e to the power minus kx. Okay, got it. Now never do this blunder of cancelling these on both the side. Okay, never do this blunder of cancelling these on both the sides. Some students, what they do, they just cancel this with this. You cannot do that. Okay, you cannot do that, because that will yield you a wrong equation. Okay, because h psi equal to e psi is the equation. You know h is not equal to e. Okay, h Hamiltonian operator is not equal to e operator. Okay, so clearly you cannot cancel this and this over here. You cannot cancel. Okay, so remember this thing. So why I have used full differentiation symbol over here? Why not partial differentiation symbol? Why full differentiation symbol? Because it is only a function of x. As it is only a function of x, so there is no t term present in it. So as there is no t term present in it, so no need to use partial differentiation symbol over here. I can use full differentiation symbol because there is only one variable. When more than one when more than one variable are involved, only then partial differentiation symbol makes sense. Okay, without more than when more than one variables are not present, partial differentiation symbol does not make any sense. Instead, we should use full differentiation symbol when only single variable is present. So I will use that now. So now you can clearly see over here that this a is a constant. Okay, a is a constant, but this term is a function of x. So while I will take the double differentiation, it will be very much crowded because this term multiplied by this term I will write. Okay, then this term multiplied by this term I will write again and again. So it will be overcrowded. So let us first find out the double differentiation of this much only. Let us first find out double differentiation of this much only. Double differentiation of this much only. Let us first find out that. Okay. So in order to do that, I will perform certain steps over here. So let me perform the steps. So d by dx, first of all I will find single differentiation. Okay. So first of all I am finding single differentiation. So for finding single differentiation, clearly one thing I can tell you that it will be like this: plus x d by dx e to the power minus kx. Okay, by the UV formula use. So it will be basically my e to the power minus kx plus x multiplied by e to the power minus kx multiplied by d by dx by the application of chain rule minus kx, right? Then it will transform to e to the power minus kx plus x e to the power minus kx multiplied by minus k. Okay, so basically you got finally e to the power minus kx. Okay, minus kx e to the power minus kx. Okay, this is the thing which you got. Okay, now I will take one more differentiation. Okay, why will I take one more differentiation? Because here there is double differentiation symbol, right? So as there is double differentiation symbol, I will have to take one more time its differentiation. So after I write one more time differentiation, okay, so I can write it like this. Got it? So this term you we have already found out. Okay, this term we have already found out. So that term will be substituted here. So after the substitution of that term, we get clearly e to the power minus kx minus kx e to the power minus kx, right? Got it? Then again we will differentiate. Okay, so after once again if we differentiate, then e to the power minus kx d by dx minus kx. Okay, minus k will be outside and d by dx of x e to the power minus kx. Okay, it will be like this. Then again this term we have already found out. Okay, this term we have already found out, which is equal to this. So I will simply substitute that this term over here. So after I make those substitutions, I simply get d2. After you do those substitutions, which I am not showing over here. Okay, after you do those substitutions, you will get minus 2k e to the power minus kx. Okay, plus k square x e to the power minus kx. Okay, so this is the double differentiation value which you got. Okay, now equation number 1 denotes, we had clearly seen this thing, that our equation number 1 had yielded us, our equation number 1 had clearly yielded us this thing. Okay, equation number 1 had clearly yielded us this thing. Okay, so basically I will just put this inside. Okay, so after I put this value inside of the bracket. Okay, so after doing that I will simply get, what will I get? I will simply get, let me show you. Okay, let me show you, only then you will feel comfortable. Okay, so a will come out. Okay, a will come out because it is a constant. Okay, so this thing. Okay, this is the thing. And plus, in the plus we have this is multiplied by. Okay, and in the plus we have v of x a here, x e to the power minus kx. Okay, equal to e a x e to the power minus k x. Okay, got it. So we this double differentiation has been already found out. Okay, double differentiation has already been found out. So in this place I will substitute it. Okay, so after I substitute it, what will I get? A minus h cut square over 2m. Okay, and what have I got? This thing. Okay, so I will basically write it in multiplication. So multiplied by. Okay, multiplied by minus 2k e to the power minus kx, minus 2k e to the power minus kx. Okay, plus k square x e to the power minus kx, plus k square x e to the power minus kx. Okay, this is the thing which you will get eventually. Okay, so plus a vx. Okay, then what will I get? A vx. Okay, x e to the power minus kx. Okay, x e to the power minus kx, right? Is equal to e a x e to the power minus kx, right? Is equal to e a x e to the power minus kx. Okay, so this is the thing. Now now I have simplified one of the operator. So basically I can cancel out some terms from the LHS and RHS. So which term is going to be cancelled out? You can clearly see this thing, that e to the power minus kx will be cancelled out. Okay, so this e to the power minus kx, this, this and this, they are cancelled out. Okay, so because you will put this common, right? If you put this common out, it will come out single, it will come out in the single form over here. Okay, the three of them will convert into a single. After I put bracket over here and write it over here, it will convert into a single thing. So basically these three, that's why are getting cancelled with this. Okay, so those are cancelled. So what do we get eventually? Okay, so clearly I get minus h cut square over 2m. Okay, minus 2k plus k square x. Okay, plus a v of x. Okay, and what have I got here? E a, right? So this is the thing which we are getting, right? Then again a will cancel out from here, here and here, right? So that is also going to be cancelled out. So after that is cancelled out, and over here one x will remain, right? One x will remain over here, right? So here also one x will remain, and here also one x will remain. Okay, because only e to the power minus kx is cancelled out, x is not cancelled out. Okay, so x will remain. So x has remained over here. and eventually you can write this simply like h cut square. After you do further simplification, you can clearly write this. Okay, it is not a big task. Okay, is equal to x e. Okay, now we have to find v of x, right? So we will take v of x to one side, okay, and other terms to the other side. So x v of x will be equal to your minus h cut square k over m plus I am writing directly now, okay, because it is a very easy step. You can do it along with me in the notebook, okay. You can do it along with me in the notebook, okay. So if you do it along with me in the notebook, you will realize that it is not a big task, because what will happen is that this multiplied by this is x term, okay. So this x term will go over here, okay, and this term will remain, and this x term will go with along with this term, and this term multiplied by this term will come out like this, okay, and this term multiplied by this term, as it contains x, so I am putting out x common from here and x common from here, and that is the result over here, okay. So hopefully you are getting. Okay, so v of x, what have I got? V of x, okay. So v of x has clearly come out to be uh, this x will cancel eventually. This x will cancel, and over here one x will come, right? So we can clearly write this thing in the form of e plus h cut square k square divided by 2m, right? It is this term, right? This term. So this term has been written now, and this term will be written afterwards. Deliberately, we are writing like that. Okay. So we have written that thing deliberately over m 1 upon x. Okay. So you got this v of x value. Okay. So you got this v of x value. So now v of x value you have got, and now it is given in the question that as x tends to a, v of x tends to 0. It is given in the question, right? Let me write this expression once again over here, okay. Let me write this expression once again over here. So when I write that expression once again over here, so it becomes basically h cut square k square over 2m, okay, minus h cut square k over 2 over m into 1 upon x, okay. So clearly as x tends to a, okay, v of x tends to 0, right? As x tends to a, v of x tends to 0. So you can clearly write this thing that put now it is given that it is tending to, okay. It is given over here that it is tending to, but mathematically we can take equal to, okay. We can take mathematically equal to. You might have learned in your JE time in the L hospital rule and indeterminate forms, all those things you might have learned in your lower classes. So L hospital rule, indeterminate forms, all those forms, uh, uh, there you have learned this thing. What does it mean by tends to? Okay, or when you have studied discontinuity and continuity in the maths, 11th standard maths. In the 11th standard maths, when you studied discontinuity and continuity, you might have learned what does it mean by tends to, okay. But for the convenience of sake of convenience, we won't go into so much intricate details of it, okay. We will such only do consider it to be mathematically equal, okay. So I have considered that to be mathematically equal to a. So when I put now v of a, it is given that when x tends to a, so v of x is equal to 0. That implies that v of a is equal to 0. Okay, so v of a is equal to 0. That means this term will turn to 0. So I will write 0 over here. Okay, so you can clearly find out e value from here, because this was given just because you are able to find out e value. Why was this given? So that you can find out e value. Now you have got the equation, so you can find e value from here clearly. From here you can find the e value. So what will the e value be equal to? So e value will be your equal to h cut square k divided by m, right? Multiplied by 1 upon a minus k by 2, which is equal to a constant. Okay, which is equal to a constant, because there is no x term in it. We have already eliminated the x by taking its value equal to a. Okay, so we have got this. Now I had already told you that whenever you get the expression for v of x, okay, whenever you get the expression for v of x, which has come out to be equal to our this much, okay, our value of v of x has come out to be equal to this much, right? So whenever you get such values, okay, so whenever you get such values, I had told you that you must क्या बोलते हैं, you must explain the result. Okay, you must explain this result. So let us explain this result in order to grab more marks for the IS exam. This is necessary. So value of e we have got. Now we will draw the graph based on this. We know this very well that it is the general equation of what? It is equal to y equal to c plus m by x. It is of this form. Okay, let us write m prime. So it is of this form. Okay, so when I put x equal to infinity, I will get y equal to c. Okay, when I put x equal to infinity, I will get y equal to c. So for the x equal to infinity, okay, and over here it is minus sign also. So when I put x equal to 0 over infinity over here, when I put x equal to infinity over here, so clearly this term will turn to 0. When I put x equal to infinity over here, this term will turn to 0, whole term. So this whole term will turn to 0. X equal to infinity पे ये पूरी term 0 हो जाएगी, right? So at x equal to infinity, this whole term will turn into 0, and anything minus 0 is that term only. So this term will remain. Okay, this term will remain. So basically, we can draw the graph based on this, and also at y equal to minus infinity, what is the value of x? Okay, that means v of x, when v of x turns to minus infinity, what will be the value of x? So clearly, in order to get v of x equal to minus infinity, we should put x equal to 0. So when I put x equal to 0 over here, I clearly get minus infinity, because this minus sign makes this term minus infinity when I take x equal to 0. Okay, and it is also given in the question that k is greater than 0. Okay, so minus into minus plus, that is not going to happen. Minus into minus plus, that is not going to happen, because it is given in the question that k is greater than 0, and clearly your mass is always greater than 0, right? So this term will be negative. Minus h cut square k by m, this term will be negative, and in the place of 1 upon x, when you put x equal to 0, this term clearly will turn into infinity. This whole term will clearly turn into infinity, and minus sign applied to infinity is minus infinity. Okay, so v of x will be minus infinity at x equal to 0, and at x equal to infinity, v of x will be constant. Okay, so based on these boundary conditions, we are going to basically draw the graph. Okay, and you have to explain all these things. Okay, you have to explain all these things in words. I have deliberately not written all these things in words. Okay, because I have already written them in words in the previous two classes, right? So in this class we I won't write it in words. Okay. For some things you must do also on your own. Okay, so it is your homework that you must write this description of this graph in your own words. Okay, after you complete this lecture. Okay, so this indicates repulsive force. I had told you that when v of x equal to v of x is greater than 0, it is repulsive force, and this part indicates it is attractive force. I had told you this clearly that when potential function is smaller than 0, it is basically your attractive force, right? So this is the thing, and we can clearly see this that value of this you can clearly see from here that this term equal to, when the v of x turn to be equal to 0, when you take v of x equal to 0, then clearly you get x equal to a. Okay, when you take x equal to a, right? When you take, you will put this value over here. Okay, you will put this value over here, and after that when you simplify and you put x equal to a, you get v of x equal to 0. Okay, so simply at x equal to a, v of x is your 0. Okay, so so you can write it in words that for the distance, this is x equal to 0, this is x equal to a, this is x equal to infinity over here. Okay, at a greater distance. So for x equal to 0 to x equal to a, from 0 to x equal to 0 to x equal to a, the force experienced by the particle is attractive. At x equal to a, no force is experienced by the particle, and at x greater than a, repulsive force is experienced by the particle. You can clearly write these things from here. Okay, so you will have to basically describe these things in your answer so that your answer looks good. Okay, you have to yourself write the words now. Okay, I told you everything. Now you have, it's your job to describe the function. Okay, means graph. Okay, so write it in words and you can get them checked by me. Okay, thank you very much. जय हिंद, जय भारत, अपना ख्याल रखें.